The most dangerous person in any room isn't the smartest person. It's the person who thinks they are the smartest. Today, I'm going to show you a simple technique that can make you genuinely smarter than people with genius IQs. In 1974, a group of Stanford medical students were given a simple task to explain the basic medical concept. These were the brilliant students, the top 1% of all applicants with perfect academic records. 85% of them failed completely. Not because they lacked knowledge, they had memorized everything required, but because they couldn't explain it simply. Meanwhile, Richard Feynman, a Nobel Prize-winning physicist, explained quantum mechanics that children could understand. He had an IQ of just 125. Smart, but nowhere you would expect from one of the history's greatest scientific minds. So what was Feynman's secret? How someone with just above average IQ became one of the greatest physicists in history? He discovered something profound. The difference between genuine understanding and the illusion of knowledge isn't intelligence. It's a specific mental protocol that anyone can learn. There is a fascinating study from Cornell where researchers asked students to rate their understanding of everyday objects, things like toilets, jeepers, and bike gears. Most students rated their understanding as quite good. But when researchers asked them to actually explain how these objects work, almost no one could do it. And you know what's the most shocking part? They had no idea how little they understood until they tried to explain everything. This gap reveals an uncomfortable truth. Your brain is lying to you right now. When you read a book, watch a lecture, or study complex material, your brain creates what cognitive scientists call an illusion of comprehension. The concept seems familiar, you know the terminology, and you nod along thinking, yes, I know this. But recognition is not understanding. Familiarity is not comprehension. Psychologists call this illusion of explanatory depth. We systematically overestimate our understanding of almost everything. You know what's the most dangerous part? This illusion just doesn't affect beginners. It gets worse with education. As your knowledge in a field grows, your familiarity and terminology creates a powerful illusion of understanding. That's why experts often make catastrophic errors in judgment. Their expertise isn't fake, but it's shallower than they realize. Consider the 2008 financial crisis. The global economy wasn't destroyed by people who knew nothing about finance, but by experts who didn't understand complex financial instruments as thoroughly as they thought they did. This isn't just an academic concern. The ability to distinguish between the real understanding and the illusion of knowledge might be the most valuable meta skill you can develop. Richard Feynman discovered that the ultimate test of understanding isn't explaining to peers. It's explaining to someone who knows nothing about the subject. His approach, now known as Feynman Technique, consists of 4 very simple steps. Step number 1, choose your concept. First, identify exactly what you want to understand. Be specific. For example, not quantum physics, but quantum entanglement. Not finance, but how mortgage-backed securities work. Write this concept at the top of the blank page. Vague topics create the perfect environment for illusion of comprehension. When you're specific, it's harder to hide from your knowledge gaps. Step number 2, teach it to a child. This next step transforms how you think. Explain the concept if you're teaching a 12-year-old child. This isn't about dumbing it down. It's about stripping away every piece of jargon, every specialized term, until you're left with pure concept. Use simple language. Use analogies to everyday experiences. Use visualizations. If you can't explain something without technical terminologies, you don't understand it well. When Elon Musk explains rocket science to his teams at SpaceX, he bans acronyms and specialized language. Why? Because they mask confusion and create the illusion of understanding. Here's what it looks like in the real practice. The complex explanation. The Heisenberg uncertainty principle states that we cannot simultaneously know the position and momentum of a particle with perfect accuracy. The Feynman explanation. Imagine trying to figure out where a baseball is and how fast it's moving. To see the ball, you need to bounce light off it. But the light itself bumps the ball tiny bit, changing its speed or direction. The more precisely you try to see where it is, the more accidentally you change how it is moving. The second explanation here doesn't just convey the information, it creates understanding. Step number 3, identifying knowledge gaps. Here is where the technique becomes brutally effective. As you explain, notice where you struggle, where you use vague language, or where you can't continue without technical terms. These are your knowledge gaps. Don't rationalize them, don't skip over them, write them down explicitly. I don't understand how, I'm unclear about, I can't explain why. This process is gold. It reveals exactly where your understanding breaks down. For example, when explaining how a car works, you might say the engine turns gasoline into energy that moves the car. That is your knowledge gap. Write it down specifically. I don't understand how the engine converts gasoline into motion. Being honest about what you don't know is the fastest path to genuine understanding. Step 4. Simplify and use analogy. The final step is to refine your explanation using stories and analogies that connect to things people already understand. This isn't just about communication. It's about strengthening neural networks in your own brain. When Warren Buffett explains complex investment strategies, he uses simple stories about businesses in his own annual letters. This isn't just for readers' benefit, it's how he clarifies his own thinking. Neuroscience confirms this approach. When you connect new information to existing mental models through analogy, you create more stronger and accessible neural pathways. Your brain doesn't store information like in a computer. It stores in the networks of associations. The more connections you create between a new concept and the things you already understand, the more accessible and useful that knowledge becomes. This is why analogies are not just explanatory tools, they are thinking tools. Let me demonstrate with something many people find challenging: compound interest. Compound interest is when you earn interest not just on your original money, but also on the interest you've already earned. It's like a snowball rolling downhill, getting bigger not just because more snow sticks to it, but because its larger size helps it collect snow even faster. When I try to explain this, I realize I need to clarify the exact mathematical process. If you have $100 and you earn 10% interest each year, the first year you get $10, giving you $110. But the second year you get 10% on $110, which is $11. Now you have $121. The key insight is that your interest itself starts earning interest. Think of it like planting a tree. At first, growth seems slow, but as the tree gets bigger, it grows more leaves, which captures more sunlight, which helps it grow even faster. That's why investors say your time is the most valuable asset. It allows compounding to work its magic. This technique isn't just a learning hack, it's backed up by neuroscience. When researchers study brain activity in people with genuine expertise versus those with shallow understanding, they find something remarkable. In people with shallow understanding, information about a topic activates isolated regions of the brain. But in those with deep understanding, discussing the same topic activates widespread neural networks spanning multiple regions. This is what Feynman Technique does neurologically. It forces the creation of these deep neural connections. A study at Washington University found that students who learned through explanation-based technique showed 45% better concept retention after 6 months compared to the conventional study methods. You know what's even more impressive? These students could apply concepts to new situations 78% more effectively. They didn't just remember information, they developed transferable understanding. This transferability is the hallmark of genuine expertise and opens up interesting paradox about the expertise itself. A fascinating paradox emerges when you apply the Feynman technique consistently. The more you understand a subject, the more aware you become of the limit of your knowledge. True experts often speak less dogmatically than the novices, because they are acutely aware of nuances and exceptions in their field. This creates what I call expert imposter syndrome. The tendency of genuine experts to question their expertise precisely because they see all the complexity in their field. Meanwhile, those with shallow understanding often speak with absolute certainty because they don't see the complexity. The Feynman technique accelerates your journey by forcing you to confront your knowledge gaps early, rather than discovering them later painfully. Richard Feynman himself, despite being one of the greatest physicists in the history, was known for his intellectual humility. When asked about quantum mechanics, he famously said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." This wasn't his false modesty. It was the awareness of genuine expert who could see the boundaries of his knowledge. The Feynman technique transforms how you approach virtually every domain. In career development, organizations increasingly value people who can translate complex ideas across disciplines. When Salesforce CEO Mark Benioff needed to explain cloud computing to investors in the early 2000s, he didn't use technical jargon. He created a simple analogy of software utility, like electricity that comes from an outlet rather than the generator you own. This clarity helped to launch a trillion-dollar industry. In problem solving, when facing the complex challenges, explaining the problem in simple terms often reveals the solution. Charles Kettering, who invented the electric starter motor, institutionalized the approach at General Motors. When engineers brought him complex problems, he would first ask them to explain the issues as if he were a child. Often in the process of simplifying, they would discover the solution themselves. In leadership, the most effective leaders use the simple language to explain the most complex situations. During the Cuban Missile Crisis, President Kennedy insisted his advisors to explain military options and its consequences in simple, concrete terms. This clarity proved crucial to avoiding nuclear war. We often make poor decisions because we don't truly understand our situations. Try explaining your next big decision to someone who knows nothing about your circumstances, using simple language and concrete examples. This process often reveals assumptions and emotional biases that would otherwise remain hidden. The 60-second Feynman challenge. Here's my challenge to you. Take 60 seconds right now to apply first step of Feynman technique. Pick something you think you understand well, maybe how a smartphone works, or why the sky is blue, or how democracy functions. Try explaining it as if to a 12 years old. No jargon, no technical terms, just simple language. If you get it stuck, congratulations. You've just discovered a knowledge gap that you can fill now. For the next 7 days, identify one concept every day that you use regularly but have never deeply questioned. Apply the Feynman technique to it. I promise the result will surprise you. Many people find that the ideas they have confidently discussed for years rest on the foundation far shakier than they have ever realized. This isn't about creating self-doubt. It's about creating authentic confidence based on genuine understanding. What begins as a learning technique ultimately becomes a philosophy of knowledge. Richard Feynman wasn't just methodical about his understanding. He was passionate about it. He had what psychologists called epistemic curiosity, a deep emotional drive to resolve the knowledge gap and achieve clarity. This curiosity transformed his relationship with knowledge. Learning wasn't chore, it was a form of play. In a world dominated by noise, by shallow opinions pretending to be expertise, by confident voices with little substance behind them, the depth of understanding might be the most valuable thing you can cultivate. Remember this, genuineness is not measured by the impressiveness of your vocabulary. It's measured by the simplicity of your explanation. As Einstein said, if you can't explain it simply, you don't understand it well enough. The reverse is also true. Learning to explain things simply makes you even understand it better. So next time, what concept will you try to explain using Feynman technique? The journey of genuine understanding might be the most important journey you'll ever take.